Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for another set of questions which are given in previous NEET exams from the chapter Moving Charges and Magnetism. In previous video, I explained till question number 5. Now let us move with question number 6. The current sensitivity of a moving coil galvanometer is 5 divisions per milliampere. And its voltage sensitivity, so that is angular deflection per unit voltage applied, is 20 divisions per volt. We need to find out the resistance of the galvanometer. Yeah, so understand that. So there is a principle. It is nothing but C theta. So this is called as restoring torque. In the concept of moving coil galvanometer, this is called as restoring torque, which is balanced by deflection torque. Deflection torque. So what is deflection torque is? N is number of turns. This is the current flowing through the coil of the galvanometer. This is area of cross section. This is B. Of course, you will also get cos theta and sin theta. So cos theta is when plane makes an angle. When plane makes an angle, plane of the coil makes an angle theta with the direction of the field. With the direction of the field. Direction of the field. So sin theta when normal drawn to the plane of the coil. So this NIAB sin theta may be associated with cos theta or sin theta. So sin theta is when normal drawn. When normal drawn to the plane of the coil, makes an angle theta. Makes an angle theta with the direction of the field. Yeah, next proceed. Okay, so ensure that theta is 0 when you go with cos theta. Theta is 90 when you go with normal. So therefore, when deflection torque is equal to restoring torque, you will get the principle. So that is NIAB is equal to C theta. Then I is equal to C by NAB with theta. So therefore, I proportional to theta. So this is the principle of moving coil galvanometer. Now, coming to the present question. Remember, angular deflection by current is equal to current sensitivity. So now theta by A will be equal to NAB theta by I. Theta by I is equal to NAB by C. So this is going to be current sensitivity. You call sigma I. Now, voltage sensitivity. The angular deflection by voltage is voltage sensitivity. Voltage sensitivity. So therefore, this can be theta by, remember definition of from Ohm's law, definition of the mathematical form of potential difference is current I is the current flowing through galvanometer with corresponding resistance G. So theta by I, this is, you call this is sigma V. Sigma V means voltage sensitivity. So sigma V is equal to theta by, look at the first equation. Theta by can be replaced with sigma I by capital G. Yeah, so now finally, you got the relation that voltage sensitivity is equal to current sensitivity upon galvanometer resistance. Now you apply the present values. So voltage sensitivity is 20 divisions per volt. Current sensitivity is 5 divisions per milliampere. Remember, per milliampere means milli means 10 to the power of -3. With the. Now This is G. So you are looking for G value. So G is equal to, this is straight away you can write 5,000. 5,000. 20 will come down because minus 3 up. So 5 get multiplied with 1,000. So therefore 0 cancelled. So answer is going to be 250 ohm. So this is given in 2018 NEET. Third option is correct. Moving to the question number 7. Ionized hydrogen atoms and alpha particles with the same momentum enters perpendicular to a constant magnetic field. So understand that this is uniform magnetic field. Ratio of their radii of their paths. So radius, which means circular path. Hydrogen describing circular path, even alpha particle also describing circular path. So if they describe circular path, we need to find out their corresponding radius. So radius of the hydrogen and radius of the alpha particle. So remember, when a charged particle enters, assume that these are just like trees in an open ground. In this direction, magnetic field is present. So suppose when charged particle is thrown, at right angles to the magnetic field, so it describes circular path. So just imagine that this circular path is parallel to the plane of the ground. Now, so there is a magnetic force acts towards the center of the circle. So this magnetic force playing role like centripetal force. This is a source formula. Magnetic force. Get back the formula of magnetic force, Q into V cross B. So V at any time is perpendicular. Suppose at this particular instant V is perpendicular to the field, or at this particular instant V is perpendicular to velocity of the charged particle, perpendicular. So therefore V cross B. So when you remove cross product, there will be sin theta. So theta will be 90. Theta is the angle between the direction of velocity and magnetic field. Get back the formula of centripetal force. It is going to be mv square by r. Okay, so we get cancelled both sides of the equation. Now radius. They mentioned that momentum to be same. So therefore mv is momentum. So ensure that whatever the point which is given in the question, so to be present in the formula, is equal to qbr. QB. So therefore momentum P is equal to QBR. Now we don't need to consider mass of the particle, mass of the charged particle, because you don't have mass in the formula. So therefore only concentrate on charge of the particle. So radius inversely proportional to, because they are in multiplication, radius is inversely proportional to charged particle. You can bring this charged particle. So therefore radius of the hydrogen 2, radius of the alpha particle. Yeah, so 1 by charge means what? This is charge of the hydrogen. So 1 by charge of the alpha particle. So therefore, charge of the alpha particle divided by charge of the hydrogen. So this is going to be get by the charge of the alpha particle. Alpha particle in general is positive. 2 charges, 2 electrons, and there is only 1 charge for hydrogen. It cancels. So the answer is 2:1. So moving to the next question. A long solenoid of 50 centimeter of length having 100 turns carrying a current of 2.5 amperes. We need to find out magnetic field at the center of the solenoid, providing the value of mu naught. So get back the formula for the solenoid at the center. B is equal to mu naught Ni. B is equal to mu naught Ni. So that N is number of turns per length, per unit length in particular. The small n is equal to number of turns per unit length. So how many number of turns? 100 turns. So therefore, you write mu naught in place of small n, write down number of turns per length with I. So mu naught is given 4 pi into 10 to the power of minus 7. Then n is number of turns, 100 turns. So these 100 turns in the length of 50 centimeters. So 50 into 10 to the power of, converting centimeter into meter, minus 2. And current is 2.5 amperes. So let us simplify this. Minus 2, so this will be as minus 5. 52 are. So therefore, this is going to be 2.5 into 2, 5. 5, 20. 5 4s are 20 and 20 pi. So 20 pi means pi value, get back pi value 3.14 along with the 10 to the power of minus 5. So magnetic field is measured in Tesla. Yeah. This is 6.28. 6.28 into 10. You understand like that. With 10 to the power of minus 5. Tesla. So the final answer is minus 4. The first option is correct. Moving to the next question. An infinitely long straight conductor carries a current of 5 amperes. An electron moving with the speed of. So this is the diagram related to the question. An electron is moving with a speed of 10 to the power of 5 meters per second parallel to the conductor. The perpendicular distance between the electron and the conductor is 20 centimeters. So in this direction, electron is moving. So the gap between the conductor and electron is 20 centimeters. Calculate the magnitude of the force experienced by the electron at that instant. Okay. So assume that there is a conductor which is carrying some current. This is the conductor. So through which current is flowing 5 amperes. According to Eisenstein experiment and Biot-Savart law principle, so there will be a field around this. So if charge is moving, if current is moving in the x-axis, so therefore, imagine in the space. So this particular plane is perpendicular to the direction of current. Formation of magnetic lines of force in the circular shape will be perpendicular. So plane of the magnetic lines of force will be perpendicular. So now charged particle is moving like this. So this is the direction of velocity of the charged particle. So what is the velocity of charged particle? That to charged particle they mentioned electron. So 5 meters per second. Now force experienced by, get back the formula for force experienced by Q of V cross B. Remember, suppose if current is flowing like this while crossing this particular point. If current is flowing from left to right while crossing this particular point, field will be outwards, which means out of the plane of the page. Out of the plane of the plane, I assume that which is coming towards you. So therefore, field will be perpendicular to the direction of velocity of the charged particle. So therefore, theta is 90 once again. After you remove cross product, anyhow, there will be sine theta. Sine 90 is 1. But what is the field here? Because they mentioned this distance as 20 centimeters. So at 20 centimeters, when current flows through a conductor, what is the magnetic field? B is equal to, use Ampere's rule, mu naught I by 2 pi R. So mu naught is anyhow 4 pi into 10 to the power of minus 7. Current is 5 amperes divided by 2 pi into. This distance is 20 centimeters. 20 into 10 to the power of minus 2. So just look at this. This is 2 times get cancelled. Then this is minus 5. This is 10 times. Then there will be one more minus 1. So therefore, this is going to be magnetic field at the point through which the charged particle is moving is 5 into 10 to the power of minus 6. Now, substituting, F is equal to, electron is moving. Electron is moving means what? Charge of the electron. Q formula is QVB. Electron means charge of the electron 1.6 into 10 to the power of minus 19. Velocity is mentioned in the question 10 to the power of 5. And magnetic field. So it is 5 into 10 to the power of minus 6. Yeah, so let us simplify this. This is minus 1. Next, so 1.6 into 5. So it is 16 5s are 80. Since there is a point, it will be 8 only. Into 10 to the power of minus 20. Minus 19, minus 1. So therefore, fourth option is correct. Moving to the next question. A uniform conducting wire of length 12A and resistance capital R is wound up as a current carrying coil in the shape. So first is which same wire is prepared as equilateral triangle of side A. The same wire in the next case, it is prepared as, it is prepared as a square of side A. The magnetic dipole moment of the coil in each case, right? So first understand that this 12A is the length of the wire, which is made as a triangle. So first we need to find out how many turns you can prepare. How many turns of the equilateral triangle you can prepare making use of 12A. So first get back the perimeter. Perimeter of the first bit, perimeter of the triangle, equilateral triangle in particular. Equilateral triangle. It is 3. So therefore, within 12A, how many turns of equilateral triangle we can prepare? So it is going to be n into 3A. So number of turns going to be, look at this, A and A get cancelled, 3 4s. So therefore, you can make a coil of equilateral triangle with 4 turns. So number of turns are going to be 4. Then next, so get back the magnetic moment formula. M is equal to number of turns, current, and area. So we need to get the area of equilateral triangle. So let us say side is A. Area of the equilateral triangle is half into base into height. So what is base? Base is going to be this. If you say this entire is A, this will be A by 2. So total is A. So therefore, then making use of this, we need to find out this height. So therefore, you call this is A, this is B, this is C, this is D. So AD we need to find out. To get AD, so we can write AB square, that is AB square as A square is equal to BD square. BD square is A square by 4 plus AD square. After simplification, A square minus A square by 4 is equal to AD square. Yeah, so therefore, this is 4A square minus A square, 3A square divided by 4 is equal to AD. AD is now H. So if you want to write AD, you take this under root. So therefore, area will be half into, base is anyhow A only, height is root 3 by 2A. So altogether area will be, N is 4 turns, I is I only, area is root 3 by 4 A square. So 4 and 4 get cancelled. It is root 3 I A square. Then next, when the same wire of 12A, length 12A is made as square coil. So first you need to get how many turns you can prepare. Yeah. So therefore, 12A is equal to perimeter of the square. It is going to be number of turns. Every turn will have its perimeter. 4A. So A and A get cancelled. A and A get cancelled first. 4 3s. So therefore, N is equal to. So you can prepare 3 turns of the square coil. Same formula once again. So M is equal to NIE. A is area. N is 3 turns. I is I only. Area of the square. Area of the square is A square. So first option is correct. I'll continue explanation for the remaining questions in the next video. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives.